In the last few videos, we built components, typed our props, and managed state with useState. But so far, everything we've built only reacts to user clicks. What happens when you need to fetch data when a component loads, or focus an input automatically, or measure a div's height? That's where today's video comes in. We're covering two of the most used hooks in React, useEffect and useRef, and how to type both of them properly in TypeScript, because this is exactly where a lot of TS React tutorials get sloppy. Let's get into it. What problem does useEffect solve? Before we touch code, let's talk conceptually. React components are basically functions that return UI based on state and props. But real apps need to do things that aren't just rendering. Things like fetching data from an API, subscribing to a WebSocket or event listener, setting a set timeout or set interval, manually interacting with the DOM, or syncing with some external system. These are called side effects because they reach outside the pure render and return cycle of a component. useEffect is React's way of saying, after you render, go run this extra piece of code. Import useEffect from React. Function example, useEffect C, console.com component rendered. Return div hello div. Run this, open the console. Every time this component renders, that log fires. Let's build on this piece by piece. The dependency array, the real power of useEffect is in its second argument, the dependency array. This controls when the effect runs. There are three variants. No dependency array runs on every render. useEffect C console.log runs after every render. Rarely what you want. It's expensive and can cause infinite loops if the effect also updates state. Empty array runs once on mount. useEffect C console.log runs once when the component mounts. This is the classic fetch data on load pattern. The empty array tells React this effect doesn't depend on anything from render, so only run it once. Array with values runs when those values change. Function user profile, user ID string. useEffect C console.log fetching data for user ID. Return div profile for user ID. Now the effect reruns only when user ID changes between renders. React compares the previous value to the current one using object is. Think of the dependency array as answering one question. What values, if they change, should cause this side effect to rerun? 3. A real example. Fetching data. Let's build something real. A component that fetches a user by ID and displays it. This is also where TypeScript starts to matter. Import useEffect, useState from React. Interface user, ID number, name string, email string. Interface user card props, user ID number. Function user card, const user, set user is useState, user null. Const loading, set loading to bleak, const error, useState string null. useEffect, let is cancelled. Async function fetch user. Set loading true, set error null. Try, const response is await fetch https://json placeholder.typecode.com/user ID. If not response okay, throw new error trees parentheses, const data. User is await response JSON. If not is cancelled, set user.data. If not is cancelled, set error instance of error.message. Unknown error. Finally, if not is cancelled, fetch user. Return to cancelled wait. If loading, return p, loading. If error, return p, error. If not user, return null. Return sentence, return pop, p is. Notice a few things. useState user null. We type state explicitly, because TypeScript can't infer the shape of data coming from fetch. Inside the async function, we don't make the useEffect callback itself async. React expects useEffect's return value to either be nothing or a cleanup function, not a promise. So we define the async function inside and call it. IsCancelled is a cleanup pattern. If user ID changes quickly, like a user rapidly clicking through profiles, we don't want a stale delayed response to overwrite newer data. 4. Cleanup functions. Any effect that sets something up, a subscription, a timer, an event listener, usually needs to tear that thing down. That's what the function you return from useEffect is for. useEffect, async, function handle resize, console.log, window resized inner width. Window add event listener resize, handle resize. Return a debuff, window remove event listener resize, end. React calls this cleanup function right before the effect runs again, and once more when the component unmounts. If you skip cleanup here, you get memory leaks. The listener keeps firing even after the component is gone. useEffect, async. Const interval ID is set interval. Console.log tick. 1000. Clear interval. Same idea. Start something in the effect, stop it in the cleanup. 5. Transition to useRef. Now let's talk about useRef. It solves a completely different problem. How do you keep a value around across renders without triggering a re-render when it changes? And, closely related, how do you get direct access to a DOM element, like an input, to call .focus on it? useRef handles both of these. 6. useRef for DOM access. Import useEffect, useRef from React. Function search input. Const input ref is useRef HTTP element, null. useEffect, input ref current.focus. Return input ref with input ref. Type text, placeholder, search. Let's break down the TypeScript here, because this is the part people get stuck on. useRef HTTP element, null. We tell TypeScript exactly what DOM element type this ref will eventually point to. We initialize it with null, because before the component mounts, there's nothing to point to yet. Input ref current will therefore have the type HTML input element, null. That's why we use the optional chaining operator, input ref current.focus, since TypeScript won't let us call .focus on something that might be null. This pattern, useRef_t, is the standard way to type a ref meant for the DOM. T should match whatever HTML element you're attaching it to, HTML div element, HTML button element, HTML text area element, and so on. Function measured box. Const boxRef is useRef HTML div element, useEffect2. If boxRef current.com console.log box height, boxRef current.offset height, and return div ref boxRef some content here div. Same pattern. Type the ref to match the element, then safely read properties off.current inside an effect, after the DOM has actually been painted. 7. useRef for mutable values, not just the DOM. Here's the part that surprises people. useRef isn't only for DOM elements. It's really a general-purpose box that holds a mutable value across renders, and updating it does not cause a re-render, unlike useState. Function renderCounter. Const renderCount is useRef number 0, useEffect2, renderCount.current plus 1. Return p this component has rendered, renderCount current times p. Compare this to useState. If we used useState here instead, every increment would trigger another render, which would trigger another increment. Infinite loop. Because refs don't trigger re-renders, we can safely track things like counts, previous values, or timer IDs, without side effects on the render cycle itself. Function usePreviousT, value t. T are undefined. Const ref is useRef_t. useEffect2, ref current equals value. Return ref current. This is a tiny custom hook that stores whatever value was passed in on the previous render. Notice the generic t. This makes the hook reusable for any type, not just numbers or strings. 8. useRef versus useState. The key distinction. Quick gut check to lock this in. Use useState when a change should cause the UI to re-render, like text typed into a controlled input or a toggle. Use useRef when you need to persist a value across renders, but changing it should not re-render the component, like a DOM node reference, a timer ID, or a previous value for comparison. If you find yourself calling .current inside your JSX to display a value, that's usually a sign you actually wanted useState, not useRef, because updating .current won't re-render the UI to reflect the new value. That's useEffect and useRef in TypeScript, how to fetch data safely, clean up after your effects, grab DOM nodes with proper typing, and use refs for values that shouldn't trigger re-renders. In the next video, we'll build on this and look at useMemo and useCallback, and when you actually need them versus when they're just extra complexity. If this helped, drop a like, share, comment, subscribe, and I'll see you in the next one.